Hi, I created a game that allows me to steer it with only gestures. It uses a deep neural network to detect and map the position of my hands. So I don't need a keyboard, I don't need a wheel, I don't need anything. Only my hands. And you can play it too if you have a camera and Python 3.6 or higher. Installation is very easy. I can shoot lasers, as you can see, by using my thumbs. The harder I turn, the faster the ship moves. I will lose on purpose. To explain to you more, I can type my name. I will, and be in top scorers. You can see in the top right corner of level 4. So with next points you getting a new level. This is from Star Wars, but I uploaded a folder from Avengers, but you can do like Game of Thrones, Hannah Montana, like wherever you like. What else? I will show you how to install it and tell you how the game works, and especially how the hands detection and getting commands from the hand works. But first let me give you a few tips of how to steer. This game is more entertaining than it looks like, because I gave it to a few people and they was just like, nah, I don't want to play. But when they saw a wheel in their hands, they like lose their minds. And they steer in a very weird way because it's not intuitive. It's completely new. So give a minute or two to adjust to this new way of steering, because they were just like do it like crazy boxing, like they even stood up, walk away from the camera. The image, the detection, the steering is as good as image. So make sure that you have a good lighting, that you are in the center, your hands are visible. There are two ways of steering. This is more like natural way with shooting like this, but if it doesn't work, you can try this, okay? And shooting will be like this, okay? Don't make any rapid movements, something like that, because the detector don't see hands clearly, they're blurry, and can get commands from it, okay? Cool. Now I'll show you the installation. Okay, so now I will show you a process of installation, and later on I will tell you what is up with that. This is how detection algorithm works for hands. But first of all, let's go to the link in the description below. It will transfer you to this GitHub repository, and you have instructions step by step of what to do. You can read them, install them with Git, with virtual environment, but I will show you the most basic way to do it, okay, for total beginners. So first thing we do, we copy the code, we download zip of the code, okay? It's about 50 megabytes, so it will take a second to download. Okay, we already have it. Then we will simply unpack it. Yeah, we can delete this. We gonna change the name, which will affect nothing. I just don't like that master end. So now we will get into the repository, and the real stuff is gonna happen. So we type cmd, and we are real developers because we have a command window. Then what we do, we scroll down. You don't have to type anything, it's too much work. We scroll down and we will install requirements. So copy and paste this here, click enter, and that's it. Then you can play. It will take a longer time with you because I have already thing installed. If you find some problems, try to upgrade pip. So copy this command, run it, and then install everything again. Remember that you have to have a Python 3.6 or higher for it to run, okay? If something doesn't work, you can find it cannot be installed, let me know. I didn't test it on Linux, so I don't know how it will work there. Okay, let's check if we can play this game. Bye Python main. Yeah, and we can play. Took me like a minute, 2 minutes. Okay. Oh, that's loud. Okay, you can change a few things here. You have a command line arguments. Things that you can change is maybe a camera. If you have a laptop with built-in camera and you plugged in another one, you can change it from 0 to 1, maybe. If you want to change a folder, if you want to add a folder, you can with any images that you have. Just remember to order them alphabetically. Okay, so they will be written in that way. What else? For me, the sound is annoying. I like to turn it off. If you want to change, you can dig into the code, maybe download the different music for that different background sound. Okay, so let's check if this gonna work. So Python main py, and the folder we're gonna go with Avengers. I don't have another camera, so I won't change it, but I will turn off the sound to false, and Python. Yeah, there's nothing like that exists. Python sound. I really cannot write. That's why I copy everything. Okay, we have no sound. We have a rocket on the level. Yeah, so everything works. I think that's it when it comes to installation. So let's go now to explanation of how it works and how the detection algorithm works and so on. So this project started a few months ago when I made a game in pygame that was steering from the keyboard. I just came across some video of pygame and it seems like a good fun, so I made a game. And I have to say that I think if you lack motivation and you want to learn how to program, this is a great way to go, because you want to program a game. You want to see the end result of it. Because a professor can give you like boring projects that you don't care about, but if you want a game, if you want to build a game, you want to play it, you want it to run smoothly, you will more likely to do it. So a pygame allows you to make a game, but it doesn't do much. All the logic you have to do on your own. Everything that happens in that game you have to design. It just helps you with it. Immediately after I did this game, I thought of the steering from gestures, because the technology existed for a few years that allows that. Maybe not smoothly, but allows that, because we have a detection. At first I wanted to detect the fists and thumbs up. Just by the detection, I wanted to use a YOLO algorithm because I was working with it at that time. I'm making a YouTube tutorial with interactive tool on YOLO algorithms. It's gonna be pretty great. So subscribe if you want to see it. But it required data, and there wasn't much of it. I would have to train it, put some time into it. So I put it on a back burner, and then I came across MediaPipe, and it seemed like a really easy tool to use. So I gave it a minute, and it worked. Like after a few minutes, installation was super fast. Making the visualization was super fast. So I think I made the steering for that game in the same day that I discovered MediaPipe. So this is a great tool. It works on CPU. It works pretty smoothly, as you can see. It's very easy to use. I mean, it's a very good tool. So I would tell you to try it. At least you can go to the site and see. The hands is one of the modules that they do, but you can do so much more in it. Like you can do a face, the mesh of the face, all of the points on it. You can do hair segmentation, box tracking, really a lot of stuff. Unfortunately, not all of them are available in Python, but if you know C++, you can do it. You can do it on Android, because those algorithms are pretty lightweight. So that doesn't require configuration of CUDA, OpenCV from source, because usually working with deep learning models or projects, it's like so much work to just start with it, because you have to configure everything, install everything, and it's rarely easy, smooth. It takes a lot of time. So like try to install Darknet on Windows. It's few hours of work. This algorithm being pretty easy to use and install is a huge plus. Okay, so let me tell you of how detection works here. Is this hands? Okay, we have hands here. So first of all, what this algorithm does, it's kind of have two steps that not always have two steps, but I will show you the... Oh, yeah, this is the workflow. So first of all, we have to detect a hand. Okay, detection. But it not actually detects a hand, it detects a palm. So this rectangle. And it's much easier to detect than hand. So they use this. They first thing they do, they downsize the image to 256 on 256 and run detection of the palm on it. Then they take a region around that palm and pass it to, they crop that image and pass it to like the next part of algorithm. And if you would have this image is in full HD, but if you would have it in 256, the hand would be like 20 pixels high and 20 pixels width. Like and you want to map 21 points, it's not enough. So we only get the parameters of that bounding box that you want to crop, and you crop it from full image, okay? So we're only finding parameters of this downsized image, and you crop from a full image, and you give it to the next part of the algorithm, okay? Then it detects this, then it finds those points, those 21 points. But it's not always works like that, because they have a function that calls static image mode. And if you have this on true, it means that you have to the algorithm treats every image like totally separate, unconnected image. But if you have it set to false, it treats as a video. So every frame is connected to the previous frames. And we can extract information from previous frames, because detection consumes a lot of computational time. It requires a lot of computation. But think about this. We have frames per second like around 25. So this hand has been here for like 200 frames, okay? So it's wasteful for us to run detection every single time if we know that hand is probably in very close proximity to where it has been before, in the frame before. So what do we do here? And we can look at the algorithm. So first of all, we go from a camera with an image to image cropping from the last frame. Then we find those hand landmarks. If the hand, no, maybe I will tell about it later. And we have a success, and we go to the next frame. But before from this hand landmark, we go to two directions. First of all, you find these points, but he also gives a new kind of bounding box, the position of new, better adjusted bounding box to this hand. Because even if I move this hand and it feels to you like I'm moving pretty fast. Remember, there is 25 frames per second, so this hand moved like a half of a centimeters per frame. So the algorithm can adjust it and shift the bounding box a bit to better catch the hand. But it sometimes happens, like you can see now, if I move this hand too fast, that it loses the hand. So what this algorithm does, it goes to the frame that the bounding box that the previous frame gave it. But if it doesn't see a hand there, if the confidence of this hand landmark is too slow, it says, I'm not sure that I can read those points from this bounding box, it runs a detection once again. So we run hands detection only in the first frames to find where we have the hand, and if we lose the hand. And it saves us so much computation because detection consumes a lot of it. Okay, so yeah, that's how it works. So I gave you a option to turn off this tracking mode. Like, it's not a tracking, static image mode, set to true, so we can see that the detection works not only slower but worse than. I don't know if it's gonna be visible here. No, it's not gonna be visible here, but if you have even a small difference in frames, that in the position of the hand, it still can handle it. If it's a too big difference, or the hand just disappearing, because right now you can't even see it because the image is too blurry, that it runs detection once again. And I thought it's gonna be a problem that in some frames you spend more time on detecting it, Like not every frame consumes the same amount of times, but I adjusted that game that if you spend more time on finding the hands, that the jump of objects will be faster. So the games works the same all the time. Doesn't matter if this frame you have to run a detection once again. Okay, what this detection gives you, what it gives you at the end result. So first of all, it gives you an index of the hand. So this is a first, this is a second, and the default value is to 2 hands, but you can have more hands. This is 1, this is 2, and the tracking mode allows you to knows that this is the first hand and this is the second hand. Then it gives you a score, so the probability that you see the hands there and you believe in the prediction, the algorithms thinks the prediction is good. And the third thing is 21 points, and the best part is they are in 3D. Yeah. It extracts the depth from 2D space, which is amazing for me. They call it sometimes 2.5D. I don't know what is that, because this depth that you can see with colors is relative to this point. Okay, so every single point here has X and Y value, and they are from -1 to 1. The same here, but the Z value, the depth, is relative to the wrist, because wrist is always around 0. And if you have a 0, it will have a dark color. So right now they have kind of a dark color, all of the points. So that means that they are kind of the same depth as Z. But if I get them closer to the camera, they are on negative values. So they are red. If I get them to that side, they are becoming green because they are positive value, because they are behind the wrist point. And the wrist point is practically always around 0. Okay, and you have what I want to say. Usually the values are negative because you holding your hands before, like in front of you. So they're usually red. So it's most likely that they will be shown as red, even if they are far behind, because who holds hands like this? Like, it's very rare. Usually hold hands like this. Maybe if you do this, it sees it as a green. If you do like this, so the thumbs is definitely far behind the wrist position, and this pinky finger is in front of it, okay? So it gives me depth, and it's useful even for me in this algorithm, because maybe I will show you of how I made the wheel and the shooting possible. Okay, and if you want to view this and experiment with this, you have the Python main steering py. Okay, there's no arguments from command line, but you can change them in the code. Okay, so how I did the steering, how I did the wheel maybe at first. I don't know, where is that? Is it in steering? Yeah. Calculate wheel. Yeah. So what I do, I have this point and I have this point. In the previous part of that video, you could see that point here, but I changed it to here because I want this to be a point of reference of how big, like for the wheel, like those points are the points of reference. And when it was this point between this and this, like this point is usually got lost when you don't see it. And this point is practically always visible if you hold your hands like this, okay? So I treat this, I take those points and I measure the distance between them. And this is the double of radius. So I measure the distance, take half of it, and this is the radius of the wheel. Then I take the center of that distance, and this is the center of the wheel, as easy as that. Then I take the angle, okay? So right now the angle is right here and here. And the degree is the way it tells me how to rotate the image of the wheel. And the rotation is pretty complicated because you can dive into the code and see it. What else? How I do detection of shooting, of thumbs up and where to shoot, when to shoot. So I made this command as safe as possible because you can sometimes, the hands will be red, like the algorithm will map them in the wrong way. So I don't want to have accidental shots. That sometimes happen, but fairly rarely. So what I do, you have to have all the fingers closed and thumbs up. And how do I measure it? It's not some crazy AI like algorithm. It's simply, I did it manually. So I can show you it right here. So here we have fingers. We treat thumb different than the other fingers. So the thumb has to be at least 250%. That distance has to be 250% of that distance. And this is where the depth comes handy. Because if I would hold my hand like this, and some people do, like that distance from this to this in 2D doesn't look like 250% of that distance, okay? But it knows this point is much darker than those, so it knows the real position is like this, and this is definitely 250% of that distance, okay? So the depth comes in handy here. The fingers work like, I think this distance has to be 150% that distance. You can adjust it if you have weird fingers. You can find the right values here. It's in steering and get hands parameters. Okay, what else can I say here? I don't know, maybe it's like some summary. I think this is a great tool and people don't use it to its full potential. Because it gives you it works on CPU, it can work on the phone like pretty easily, and it gives you so much possibilities to use. And I would advise you to check it out at least, to try to build something with it. You can see, I don't know if I told you before that. I think I told you about the colors of that. Okay, so I think that's it for that video. It doesn't come to mind what else can I say. So maybe thank you for watching. If you have any tips of how to make that game better, because I didn't want that game to be super cool, like I just wanted to use that technology. If you have any ideas how to make it better, I have a few on my own, but I will gladly listen to you. So leave a comment section, maybe give me a thumbs up, all that stuff. And if you want to see that YouTube YOLO tutorial, I will release it, I think, pretty soon. I already have the tool built for it. So hopefully see you soon, and thanks for watching. Bye.